Road to Olympiad.
Welcome to RTO. Consider the following problem. Two non-congruent integer side isosceles triangle have the same perimeter and the same area. The ratio of the length of the bases of the two triangles is 8:7. Find the minimum possible value of their common perimeter. Shapes with same perimeter and same area may not necessarily have the same dimension. This problem will be a very good example for that. Today it is almost 1 year since the first video on competitions problems. In today's video, we will be showing two different solutions. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by letting S be the common semi-perimeter. And since the ratio of the base length are 8:7, we can let the base length be 16x and 14x respectively. Here, we choose the length to be 16x and 14x rather than 8x and 7x for the ease of calculations next steps. With the base length, we can calculate the length of each equal side of the triangle with larger base be 2s minus 16x the whole thing over 2. This is simply equal to s minus 8x. Similarly, we can find that the length of each equal side of the triangle with the smaller base is equal to s minus 7x. Getting all the three sides lengths of the triangles, we can now calculate the area of each of the triangles by using the Heron formula. Here, the area of the triangle with larger base is this one, and the area of the triangle with smaller base is this one. It is given that the area of this triangle are equal, and we can simplify the equations to get this one. Squaring both sides and rearranging the equations, we get 15s is equal to 338x. Since 15 and 338 has no common factors other than 1, or in other words, they are relatively prime, in order for the equation to be equal, the smallest semi-perimeter s we can have is 338, which corresponds to the value of x is equal to 15. Thus, the smallest common perimeter of the triangle is 676, and this marks the end of our solutions. Now, let's move forward for the second solutions. Here, we can let 16x and 14x be the base lengths of the triangle respectively. Also, let n be the length of each of the equal side, and h be the height of the triangle with the larger base. Since the triangle have the same perimeter and the same area, we can easily find out that the length of each equal side of the triangle with the smaller base must be equal to x plus n, and its height must be equal to 8/7h. Notice that the height cuts the base of each isosceles triangles into half, so by using the Pythagoras theorem, we can find the height of the triangles with the smaller base be this one, and the height of the triangle with the larger base be this one. We know that the height of the triangle of the smaller base is equal to 8/7 of the larger one, so we have these equations. Squaring both sides, expanding the square, multiplying the 49, and expanding the brackets, we get this. We can rearrange the equations into this one, where we can factorize as follows. Solving the equations give us n is equal to 218x over 15, or n is equal to negative 8x. We reject the second solutions as we need n and x to be both positive, which is impossible in this case. Similar to the first solutions, since 218 and 15 are relatively prime, The smallest x and n we can have must be 15 and 218 respectively. With this, we can calculate the smallest parameters to be 16 times 15 plus 2 times 218, which is equal to 676. And this marks the end of our second solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.